Hey guys, welcome back to another video. So here we'll be focusing on a full 3D Pythagoras and trigonometry walkthrough, and this one specifically focuses on the IGCSE for Edexcel as well as the GCSE for Edexcel and AQA and a bunch of other exam boards. So the main purpose of this is to go through 4 maths papers which were previously released in the last few years, and they focus specifically on the harder concepts, like not just the cuboid but also different 3D shapes. Okay? And we're going to go through a couple like topic review first, like what's actually going to come up. So on this slide, as you can see, we've got a cuboid here, and for a cuboid, the main idea is the fact that we're trying to find the length of D, which is the longest diagonal from one end of the cuboid straight to the other corner. And the tactic of it is that you can see that we got a 2D right angle triangle, but the main idea is the fact that we go around the shape, around the B, A, and C, to such a way where we have a squared plus b squared plus c squared gives you the long diagonal squared. Okay, so that's the main idea, but they can be applied for a bunch of other shapes. Now, next, we also have 3D trigonometry. Now, this part is kind of a bit of a step up from 3D Pythagoras, because there's two main things they usually ask in the exam. The first one is to find the angle between the line and the plane. Now, plane means like the ground of it, the base, the flat. And the angle between the line and the plane is literally like, here's your line and the plane is here. This would be the angle right there. So it's kind of like an angle mid-air. And in a way, you can always form a right angle triangle, because going straight down from any point in line always makes a perpendicular right angle triangle. That's where trig gets involved. So you got to make sure you're comfortable with your Sohcahtoa. Now, besides that, they might get a bit more complicated, and they might get sine and cosine rules involved as well. And here's like a little demonstration. So you got a regular cuboid, and for some reason you're trying to find, I don't know, some sort of area here, or maybe an angle between AEH. Okay, now look at this carefully. Once you've deduced all of the lengths of these diagonals using 2D and 3D Pythagoras, you can eventually solve it normally using cosine or the sine rule. And that's it, guys. That's pretty much like the main concepts done. Now from this point on, we're going to have a look at 4 past exam videos. So I'll see you guys in a bit. Ciao. So here is a cube, A, B, C, D, E, F, G, H. Why did I say that? Where M is the midpoint of the edge GH. So M is bang in the middle. Find the size of the angle between the line MA, so M connecting to A, and the plane ABCD, so the ground. Okay, with these kind of questions, they're always the same. Now the good thing about this problem is that we're dealing with a cube, so every length is the same. And because they don't give us a length, well, we can just make one up. I'm gonna go ahead and just pick a length of, I don't know, 2. So this is gonna be a 2 by 2 cube. So 2 is all the way around. Now let's go ahead and draw the line they want. So they want the line from M all the way to A, and they want an angle between that and the plane. Now this is the bit where people get tripped up. To find the correct angle, all you have to do is basically draw a vertical line downwards. So again, this will be midway through this line BC, and then connect it across like that. Now you can kind of see that this line is trailing across the ground, and this line here is also perpendicular, because this is vertically upwards and this is on the ground. Now all you want to do here is literally work out the length of, I don't know, one line. Let's say this diagonal D. Now to do it, this is just a case of 3D Pythagoras. We need to find the length around A to B, B to this midpoint here, and then this midpoint all the way up to M. And we got the lengths. We know this length is 2. This tiny length, which is half the distance, must be 1. So using 3D Pythagoras, we can say that A squared plus B squared plus C squared must equal D squared. So it'll be 2 squared plus 1 squared plus 2 squared equals D squared. Okay, and then just putting this in your calculator, you're going to get 9, so 9 equals D squared. So therefore, square rooting that, D is going to give you 3. Now this will be the diagonal length. Now, literally taking this right angle triangle outside the purple triangle, we're going to have a triangle that looks a bit like this. So we know that the diagonal length is 3. We're trying to find this angle between, and we got what's it called, a vertical length of 2. Now all you guys want to do is refer back to Sohcahtoa and just pick the right pairing that we're going to deal with to solve this. So looking at this, we can see that opposite the angle we got the opposite, which is O, and this long diagonal length is the hypotenuse, because it's always opposite the right angle. So we're going to deal with so because we've got an O and a H. We don't have adjacent or neither one. So therefore, we can say that remodeling it using Sohcahtoa, we can say that we have sine of the angle equals the opposite O over hypotenuse 3. And then sine inversing this, you're going to get a simple result of 41.8 degrees. That's it. All done. So the diagram shows a triangular prism. Okay, I bet you're going to have to find a diagonal line and probably angle between the plane. So AF is 10, AB is 24, and BC is 8. Angle FAB and ADC and BCD are all right angle triangles. They're all 90 degrees. So yeah, we see that there. Work out the size of the angle between the line BE, which is this line here, and the plane ABCD, so the ground over here. Give your answer correct to 1 dp. Now, let's go ahead and run this real quickly, yeah? To work out the angle between the plane is always basically the line which is the diagonal which is the furthest corner from one point of the 3D shape to the other side. So for instance, this line BE. This is the furthest line across. Now, one thing to note is that when you want to make an angle to the plane, it's always safe to assume to do it from this corner to his other opposite corner on the ground. For instance, here. And this would be the angle of interest they want. Let's call it theta, yeah? And one thing to note is that when you're trying to figure out an angle over here, you have to realize that you're looking straight down at the ground. And this would, of course, have to be perpendicular. So this is actually a right angle triangle. So if we just consider right now EDB, yeah, just put on the side. This is how it looks like in 2D form, yeah? And we're trying to find this angle here. And it doesn't look so bad now. First things first, we have this length, this vertical length here, ED. It's right here, FA, which is 10. So this is 10. The only thing we need is this long diagonal D. And that is easy. To find the longest diagonal, you just work your way around using 3D Pythagoras. You got 8, 24, and 10. So D is basically equivalent to this. So we can say that using 3D Pythagoras, D squared will be equal to 8 squared plus 24 squared plus 10 squared. And then you just literally solve it. Now I did this already, yeah? I got 740. And square root that, well, I just called it root 740. Your calculator will give a simplified answer, by the way, yeah? Now, over here, so since we got D equals root 740, so I'm going to quickly update this here, yeah? So root 740, you can just look at this and say, hey, this is just easy trig now. So this is just simple Sohcahtoa. And all you got to do here now is just observe what we need. So let me just change the colors. So looking at this carefully, the angles here, we got the opposite and we got the hypotenuse. So O and H. And the only thing that has O and H is so. So this means we're going to have the sine of the angle, which is theta, equals opposite 10 over hypotenuse H. So root 740. And that's it, guys. All you're going to do now is literally sine inverse. So I've got that. Sine inverse your final result. And you lot should get, let me see, root 740. And I got 21.6 degrees. Was it 1 dp? That's it. That's literally it, guys. Triangle PQR, so PQR, so this right angle here, has the following dimensions: 20 centimeters across, an angle 30, and across it PM is 12, whereas PQR, this part is a right angle. So this one looks like a typical Pythagoras theorem or 2D trigonometry, the regular trig. Calculate the size of the angle that the line MR, so this one, makes with the plane. Okay. So in these kind of questions, when you want to find an angle to the plane, usually it's always the cross section, so it's always from here. So this is the line. So you always got to think of the diagonal. This helps a lot. So your angle, so your triangle you're really interested in is this part. And this is the angle of interest. Okay, so let me just pull that to the side. So I'm gonna make it look a bit like this. So angle alpha, and we know a couple dimensions, I believe, or do we not know anything? Okay, so yeah, so we need a couple information. So we need to find the length of this part of the base, the length of the height, and the diagonal cross section. This one can be found using 3D Pythagoras. So we can find the length of this a squared, this base squared plus this height squared plus 12 squared.
and that could give us our D. To get this height, well, we need the length PQ. The diagonal cross section, we need this diagonal, this base length here, so we can match it with 12, which is the same here. Okay, so let's have a go. Let's have a go working everything out here then. Okay, so first thing you want to do, so let's work out this length here so we can match it to this length here. I'm going to call this one X. Okay, let's call this one Y because we need this length too. So for X, we can use simple 2D trig, so Sohcahtoa. So at this stage, your trig has to be very good. Okay, it has to be very, and you have to spot things. So we have the opposite way of hypotenuse. So we're looking at so we can say in equation involving x, we can have sine 30 equals opposite over hypotenuse, so x over 20. Therefore, times in 20, x must equal 20 sine 30. Let's just leave that for now. As for y, we need to use trig again, so it'll be adjacent over hypotenuse, because remember this is the angle, that's the opposite, and that's going to be ka. So it's going to be the same style, but except this time you eventually get 20 cos 30. Okay, so you can use the same formulation, but you'll get these two results. That's perfect. So that means this height here is the same as this height here. So this height is also x. So that's good. Now the diagonal length d, let's call this d, the big diagonal. That's basically y squared plus x squared plus 12 squared will give us a d squared. So let me call that d. So that's going to be d squared equals x squared plus y squared plus 12 squared. We know what x squared and y squared is. It's just the square of these two guys. And we can find the value of d. So let's do that now actually. So this is going to give us, in your calculator, put 20 sine 30 all squared, so bracket 20 sine 30 squared plus, next one, so I'll do it here, 20 sine 30 squared plus 20 cos 30 squared plus 12 squared. Okay, it's going to take some time. 30 squared plus 12 squared. Okay, this gave me 544. Okay, I hope that's okay. Let's just check everything's alright. 20 cos 30. Yep, looks fine to me. And that means d must equal root 544. So I'll just leave it as that, root 544. Just to make the equation easy. We also know that this length here is x. So the ML is x, so we can call this one x, which is obviously 20 sine 30. Now that leaves us with this length here, the last diagonal, the last length here. So what is it? So we have oh no, we know this length is 12. That means we can use another 2D Pythagoras to get this length. So this one we know is 12, and this is y. That means this length here, let's call it z. Okay, let's call this length z. 2D. Okay, so let me just do it here. So z squared equals oh god, I keep forgetting. Y squared plus 12 squared. Okay, squared plus 12 squared. Now we remember that y squared was 20 cos 30, so 20 cos 30 squared plus 12 squared. What does that give us? So again, in your calculator, there's a lot of working out here, isn't there? Okay. Okay, this gave me 444. Okay. That means z is just root that value. Just keep it as a third, it's easier. Now we're finally getting somewhere. And you know what, let's just put 20 sine 30 as well, just to clear it out. 20 sine 30 was actually 10. This whole time this was 10. Easy value. So that means we're going to have a triangle now, so I'll redraw a triangle here. With alpha here, so this length is 10, this is root 544, root 444. Voila, that means to work this out we need to use the cosine rule now. So yeah, we're getting somewhere guys, we're getting somewhere. So this means cosine rule time. Okay, let's try this out. So with the cosine rule, we need to label a couple of things. So this one we have to always label A and the angle A. So the length is always reflective to opposite the angle itself. So the general formula is a squared equals b squared plus c squared minus 2bc cos A. You should find this formula in the beginning of the book, so it's in the formula sheet. Now we'll just pop in all the values. So you go a squared is 100, b squared and c squared, these are these two lengths. Just square them both so you get the whole numbers of 544 plus 444 minus 2 times root 544 times root 444 cos alpha. Now let's tidy those up. So all these values here, so what do we get? Okay, so cos alpha is going to equal, okay, so there's a lot of algebra, so it'll be 100 the left hand side minus these two values, so let me add them up, 544 plus 444, which is 988, so minus 988 over, and then let's work out these ones and then divide it across, minus 2 times root 544. So basically you guys just make sure you just plug everything in and just try and get the result. Okay, you know what, actually let's just keep it as is, because I checked on the calculator and you don't get a very nice answer. Okay, now once you put in the calculator you get a certain figure and then you want to cos inverse it, 25.4 degrees to 1 dp.
So let's check it out. The diagram shows a pyramid with horizontal base A, B, C, D, E. Okay, so it looks like a pentagon to me. This shape is a regular pentagon. In other words, every length is equal and so is the angles, with center O and side 8 centimeters. Okay, let's keep everything in right now, yeah? The vertex P is vertically above O, so this is O, then it's vertically above that here, there's P. The length of it is 10 centimeters, so O to B is 10. Calculate the size of angle A straight to P down to the midpoint M. Alright, so this is the kind of angle we're looking at, this kind of weird shape. So let's just have a careful think here. Now, to solve this kind of weird 3D trig problem, my advice is to firstly work out what are the angles between this interior pentagon. Yep. If you can work out the angle of an interior pentagon, then you pretty much got it. Now the trick is, for a regular shape, the interior exterior formulas are these. So we should know that every interior plus an exterior must add up to 180 degrees. We should also know that the exterior is calculated from 360 over the number size. In this case, it's a 5-sided shape divided by 5. Doing so, you should get 72 degrees. Now, when you got that, you're pretty much almost done. We can see that, therefore, if the exterior is 72, that means 180 take away the exterior must give us an interior of 108 degrees. Now, almost done again. So let's go ahead and visualize the shape, yeah? So let's try and draw some lines over here. I'll explain as we go along, yeah? And we're going to get some objectives. So the target is try and find out some angles here and then try and work out the length from O to M, yeah? So M is the midpoint, so we need this kind of straight line here. And by the way, guys, since M is in the center of two lines, if you just pretend M is here for a second, you'll realize that you get a right angle triangle here, right angle triangle here as well. Now I'm just going to pull out the shape for a second, yeah? This BOC shape. Okay, we know that whole thing is 8. We know that if the whole interior is what? 108 degrees, and because every shape is practically the same, that means this is half the angle. So half of 108 will give us 54. We can also show that if we half the line across, so like half it here, we're going to have a length of half of 8, which is 4, and a right angle triangle here. So that's our shape now. So with this, we can actually find out the length from here to here, from O to this midpoint M. And we can do this using, what's it called? Sohcahtoa. So I'm going to draw the shape of here now. And we're going to call this, what's it called? We're going to call this length here. What should we call this length? Just call it X, yeah? To find the value X, and we've got a length of 4 here. We've got an angle of 54 degrees. Now, using Sohcahtoa, so Sohcahtoa. So guys, just let me know in the comments how you're finding it so far, yeah? To find X, we just need to recognize everything here, yeah? X is opposite 54 and 4 is adjacent. So we've got O and A, opposite and adjacent. The only thing that's O and A is TOA. So this equation is now tan of the angle, which is 54, equals opposite over adjacent. And then solving this for X, you're going to get X equals 4 times tan 54. This should give us a length of 5.51 centimeters. So that's so just quick recap. So we just found the length from the midpoint to the center, yeah? And we're going to see this in a second. You're going to see all of this is going to work out nicely. So I'm going to just update this quickly. Give me a second, guys. So far we got this length here, which is perfect, yeah? We can see that right to the base is always perpendicular to the base, so it's right angled here. We've got length here, which is 5.51. We know the height is 10. We can easily work out this angle from here to M. Remember, we're trying to go to M. Oops, M is there. We can call this angle Y. Now, the only thing we also need now is a length from A to the center, because once we work out this length here, Y, then we can work out, oh, okay, I'll use Y. Let's call this one W. We work out this length here, then we can work out this last angle Z. Okay, that's the target. So we're going to come back to this this blue triangle here. Let's work on the red triangle. So now, how to get the length from A to the center? Okay, so just to recap on our lengths. So I'm just going to just draw this again, this triangle here. So we've got A to the center to B. We said earlier that this is a length of 8. We got an angle of 54 on both ends. We also got, so therefore the remaining angle here, so 54 plus 54 is 108 degrees. 180 take away that is 72. So we can use, what's that called again? We can use the sine rule. If we call this length W, like we said, we could use the sine rule to work out that length. So from the sine rule, we have W over its opposite, which is sine 54. This must equal 8 over another pair, sine 72. So from 8 to sine 72. And then just timesing and just evaluating the right side, then multiplying sine 54 across, you should get a length here of 6.81 centimeters. Yeah, so W 6.81. Okay, guys, so now we're almost done, yeah? We're almost done. So the point is, yeah, once we work out the length of the angle Z and Y, we essentially got the complete angle, because we'll find an angle between A, P, and M. And Z is between A and this line, and Y is between that line and M. Combining these two will give us the full angle. Alright, so far so good. Now, I think I need some extra space there, don't I? Let me just scroll down a bit. So this is the current shape we have here. 6.81 here, angle Z, and length 10. Okay, so looking at this carefully, we have an opposite and adjacent. So this must mean, according to our Sohcahtoa, it has to be Toa again. So this would be tan of the angle Z must equal the opposite over the adjacent. And then evaluating this using the tan inverse function, you should get 34.3 degrees. Now likewise for the blue triangle here, so let me change the blue. We got, let's see, all right, so I'm gonna put it down here. Blue triangle here. You got 5.51, you got length of 10. We call that angle Y. Okay, again, same thing applies. You got an opposite and adjacent, so it's Toa. So tan Y equals 5.51 over 10. Doing the inverse of that, and you should get 28.8 degrees. And therefore, we can say that the total angle APM, which is from Z plus Y, so angle APM equals literally Y plus Z. Summing these up, you should get 63.1 degrees. And that's it, guys. I hope you enjoyed this video and this last question, you know, and let me know what you guys think. Like, if you got any other suggestions, any other tips, if you understood everything. Otherwise, I shall see you guys next time. Ciao.